I hope all of you are doing good. Let's start today's chapter, more about triangles. Introduction. In the previous class, we have learned about different types of triangles. We have also learned that one, in a triangle, the sum of angles is always 180 degree, angle sum property. And two, the sum of any two sides of a triangle is greater than the third side, triangle inequality. A triangle has many other interesting properties too. In this chapter, we shall learn about the properties of an isosceles triangle, the famous Pythagoras theorem and concurrence properties of medians, altitudes, right bisectors of the sides and bisectors of the angles of a triangle. We shall also verify these properties while solving problems. Okay. Number one, properties of isosceles triangles. As we know, an isosceles triangle has two equal sides. Then what about its angle opposite to these? Let us consider an activity. Activity 1. Construct a triangle ABC with AB is equals to 6 cm and BC is equals to AC is equals to 5 cm. Because in an isosceles triangles, two sides are equal. That's why we have taken these two sides equal. Then measure angle B and angle C and calculate angle B minus angle C. Repeat this activity with two other isosceles triangles with different lengths or side. In each case, label the triangle as ABC with BC is equals to AC. We write the observation in the form of a table as shown below. Okay, so you will write your observation in this table. So what do we observe? We observe that in each case the difference angle B minus angle C is either 0 or so small that the same may be treated as 0. Thus we have angle B is equals to angle C. Activity 2. Construct a triangle ABC with AB is equals to 6 cm and BC is equals to AC is equals to 5 cm. Trace a copy of triangle ABC, fold it in such a way that AC falls along BC. Press to get a crease. We observe that angle B covers angle C exactly or angle B is equals to angle C. These activities illustrate that in a triangle, if two sides are equal, then the angle opposite the equal sides are also equal. Or in an isosceles triangle, the angle opposites to the equal sides are equal. Remember that. And activity 3. Construct a triangle ABC with angle B is equals to angle C is equals to 60 degree and BC is equals to 7 cm. Measure the sides AB and AC, find the difference AB minus AC. We repeat the above process with two other triangles, each named ABC with different measurements such as angle B is equals to angle C. The observations are written in the form of a table as shown below. Okay, so you will write your observation in this table and then what do we observe? The table will show that the difference AB minus AC is either 0 or so small that can be considered as 0. Thus, AB is equals to AC. Okay. Activity 4. Construct a triangle with angle B is equals to angle C is equals to 80 degree and BC is equals to 6 cm. Trace a true copy of the triangle ABC. Fold it in such a way that C falls on B and the two parts of side BC cover each other exactly. Press to create a crease. We observe that AC covers AB exactly. This shows that AB is equals to AC. These activities illustrate the following fact. In a triangle, if two angles are equal, then the side opposite to these angles are also equal. Okay. Example 1. In an isosceles triangle, a base angle is twice as large as the vertex angle. Find the angles of the triangle. Okay. Let ABC be an isosceles angle with AB is equals to AC. Okay, and angle AB, the vertex angle, this is the vertex angle, and angles B and angle C, these are the base angles. Now, vertex angle is given here. How much is there? Base angle is twice as large as a vertex angle. So, let the vertex angle be. Let the vertex angle be x degree. That means this is x degree. Okay. Okay. Now the base angle is twice as large as the vertex angle. That means 2x. This is also 2x degree. Now we have to find the angle. So sum of three angles is x plus 2x plus 3x is equals to 180 degree. Okay. These are also in degree. Why? Because of angle sum, by angle sum property of triangle. 3 plus 2, 5 plus 1, 6x is equals to 180. X is equals to 180 by 6 and x is equals to 30. So, angle A is equals to 30 degree and angle B is equals to 2x, that is 2 into x 30 degree is equals to 60 degree. and angle C, that is also 60 degree, right? Exercise 19.1. In triangle PQR, okay, let's make a triangle PQR, okay, PQ is equals to QR. Now, which of its angles are equal? Okay, angle opposite to this side is this, and angle opposite to this side is this. That means angle Q and angle R, these two angles are equal, okay. Pythagoras theorem. Pythagoras, a famous Greek philosopher born in about 550 BC, proposed a relation between the sides of right triangle. It states that in a right triangle, the square of the hypotenuse equals to the sum of the squares of its remaining two sides. Let triangle ABC a right angled at B. Not like this. Right angled at B. That means this is A, this is C, okay. And AC, B its hypotenuse, and BC its base. BC is base, AC is hypotenuse, okay. So, here are the right triangles, measurement ABC, squares of AB, then squares of C, and then difference. So, every time you will observe that in each case the difference C square minus A square plus B square is equals to 0, or C square is equals to A square plus B square, okay. Corollary. Consider triangle ABC, right angled at C, okay, and let AB is equals to C, AB is equals to C, BC is equals to A, and AC is equals to B. Then hypotenuse square is equals to base square plus perpendicular square, okay. Hypotenuse is what? AB, AB square, base is what? BC, BC square plus perpendicular is what? AC, AC square. That is C square is equals to A square plus B square, right? And where AC is equals to, AB is equals to C, BC is equals to A, and AC is equals to B. Now, let's verification. To verify triangles, the truth of this theorem, we draw 3 right triangles and label each as triangle ABC, right angled at B. In each case, we take the measurement of ABC and calculate the result as follows. See, by Pythagoras theorem, we have C square is equals to A square plus B square. C square is greater than A square, and C square is greater than B square. C is greater than A and C is greater than B. Thus, in a right triangle, the hypotenuse is greater than each of the remaining two sides of the triangle. Next, converse of Pythagoras theorem. Converse of Pythagoras theorem can be stated as, if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle with the angle opposite the first side as a right angle. In short, if in a triangle ABC we have AB square is equals to BC square plus AC square, okay, or you can say C square is equals to A square plus a B square, then the triangle is a right triangle, right angled at C. We shall verify this by the following activities. Activity 1. Draw triangle ABC with AB is equals to 5 cm, BC is equals to 3 cm, and AC is equals to 4 cm. Okay. So here C square is equals to A square plus B square. We will take this formula. C is what? 5 square. A is what? 3 square plus 4 square. Okay. 5 square is 25. 3 square 9. 4 square 16. 25 is equals to 25. Okay. So measure of angle C is what? 90 degree. Activity 2. Draw triangle ABC with sides AB is equals to 10 centimeter, BC is equals to 6 centimeter, and AC is equals to 8 centimeter. Then C square is equals to A square plus B square. C is what? 10 square, A is 6 square plus B is 8 square. 100 is equals to 6 square is 36 plus 8 square is 64. That is 100. Okay. And if we measure angle C, it will be 90 degree. Thus we say that converse of Pythagoras theorem is 2. The three integers a, b, c in the relation c square is equals to a square plus b square are the often known as Pythagorean triplets. Okay. Example 1. The hypotenuse of a right triangle is 25 centimeter. If one of the remaining two sides are 7 centimeter, find the length of the third side. Okay. Let's do it. So, let triangle ABC is a right angled triangle, right angled at C. ABC. One of the side is 7, okay, and hypotenuse is given 25. Now we have to find AC. According to Pythagoras theorem is AB square is equals to AC square plus BC square. Right, we have to find AC square. So, AC square is what? AB square minus BC square. AC is 25. 25 square minus 7 square. Square of 25 is 625 minus 49. Okay, 625 minus 49 is 576. Now, how will we know, how will we get to know that what is the square root of 576? We will find the square root of 576. Okay. 2 2s are 4, 1, bring down 76, 4. Then 4. 4 4s are 16 and 1 carry 17. So 24. That means 576 is the square of 24. Okay. And AC is equals to 24 centimeter. Okay. Exercise 19.2. Triangle ABC is a right triangle, right angled at C. Right angled at C. AB. Okay. AC is equals to 9 centimeter. BC is equals to 12 centimeter. Find the length of AB, that is this side. So, AB is what? AB square is equals to AC square plus BC square. Okay. AC is 9 square plus BC is 12 square. 9 square 81 plus 144. Okay. AB square. Now, AB square is what? 4 plus 1 5, 4 8 plus 4 12, 1 carry, then 2 225. 225 square of 15 is 225. That means AB is equals to 15 centimeter, right? Medians and centroid of a triangle. Median of a triangle is a line segment that joins a vertex to the midpoint of the opposite side. Since a triangle has 3 vertices and has 3 sides opposite to each of the vertices, for each vertex there is a median of the triangle. Hence, a triangle has 3 medians. How to draw median? We follow the steps given below. Number 1, obtain the triangle ABC with B as a center and radius more than half of BC. Draw arcs on each side of BC. Then with C as center and the same radius, draw 2 arcs cutting the previous arcs at point P and Q. Third, join PQ meeting at D, the midpoint of BC. 4, join AD to obtain the median AD. Similarly, we can draw medians from B to C. Next, concurrence property of medians of a triangle. When we draw all the 3 medians of a triangle, we will observe that they all meet at a point, we often denoted by G, capital G. Okay. The point of concurrence of the medians of a triangle is called the centroid of the triangle. Some properties of centroid and medians of a triangle. Following are some properties of a centroid. Number 1, the centroid of a triangle divides each median in the ratio 2:1. 2, the medians of an equilateral triangle are equal. Remember that. 3, the medians to the equal side of an isosceles triangle are equal. Number 4, median to the base of an isosceles triangle is perpendicular to the base. Example, AD is the median of the equilateral triangle ABC. Okay, this is the median. Now we have to prove that 3AB square is equals to 4AD square. Okay, ABC is an equilateral triangle. Okay, and AD is perpendicular to what? BC. right? Now, by Pythagoras theorem, in triangle ABD, you can write AB square is equals to AD square plus BD square, right? Now, AB square is equals to AD square plus, you can write it as half BC square because BD is half of BD, right? So, you will write half of BC square. Now, AB square is equals to AD square plus 1 by 4 BC square, okay. Since it is an equilateral triangle, all three sides are equal. So, we can write here AB also instead of AC, BC. So, we will write AB square is equals to AD square plus 1 by 4 AB square, okay. Reason given here. Now, AB square minus 1 by 4 AB square is equals to AD square. Now, take the LCM 4. 4 AB square minus AB square is equals to AD square. Now, 4AB minus 1AB square is 3AB square, and we will transpose 4 to this side, 4AD square, okay. Hence proved. Altitudes of a triangle. Altitude of a triangle is the line segment from a vertex of the triangle perpendicular to the line containing the opposite side. Clearly, each triangle has 3 altitudes, one from each vertex. Construction of altitudes by using ruler and compasses. We follow the steps given below. Number 1, draw any triangle ABC. 2, with A as center and a suitable radius, draw an arc cutting BC or BC produced at 2 points P and Q. 3, with P as center and radius greater than 1 by 2 PQ, draw an arc on the opposite side of A. 4, with Q as center and with the same radius, draw an arc on the opposite side of A, cutting the previously drawn arc at R. 5, join AR, let it cut BC at L, then AL is the required altitude. Okay. Next, concurrence property of altitudes of a triangle. When we draw all the 3 altitudes of a triangle, they meet at a point. The point of concurrence of the altitudes of a triangle is called orthocenter of the triangle. Some properties of altitudes. After measuring the lengths of the altitudes of different types of triangles, the following properties are established. The altitudes of an equilateral triangle are equal. Okay, the altitudes bisect the base of an equilateral triangle. 3, the altitude drawn on the equal side of an isosceles triangle are equal. Now, properties of orthocenter. Orthocenter has the following properties. Orthocenter of an acute angled triangle lies in the interior of the triangle. 2, the orthocenter of a right triangle is the vertex containing the right triangle. And number 3, the orthocenter of an obtuse angle triangle lies in the exterior of the triangle. Perpendicular bisector of the sides of a triangle. The perpendicular bisector of a side of a triangle is the line that is perpendicular to the side and bisects it. A triangle can have 3 perpendicular bisectors as it has 3 sides. Now, construction of perpendicular bisectors of the sides of the given triangle. We follow the procedure given below. Number 1, draw a triangle ABC. 2, with center as B and radius greater than half BC, draw arcs on either side of BC. Then with C as center and the same radius, draw arcs to cut the previously drawn arcs at P and Q respectively. 3, join P and Q. PQ is the required perpendicular bisector. Similarly, we can draw perpendicular bisectors of the other 2 sides as shown in this figure. Okay. Concurrence of perpendicular bisectors of the sides of a triangle. As we observe, the perpendicular bisectors of the sides of a triangle meet at a point. The point of concurrence of the perpendicular bisectors of the sides of a triangle is called the circumcenter of the triangle. Now, properties of circumcenter. From the constructions, we observe that the following are the properties of circumcenter. Number 1, the circumcenter of an acute angle triangle lies in the interior of the triangle. 2, the circumcenter of a right angle triangle lies at the midpoint of its hypotenuse. 3, the circumcenter of an obtuse triangle lies in the exterior of the triangle. And 4, the circumcenter of a triangle is equidistant from its vertices. Equidistant means at equal distance. 5, the circle passing through the vertices of a triangle is called a circumcircle. And 6, the radius of circumcircle is called the circumradius. Now, angle bisector of a triangle. An angle bisector of a triangle is the line segment that bisects an angle of the triangle and has the other end on the side opposite to it. Concurrence of angle bisectors of a triangle. The angle bisectors of a triangle are concurrent. The point of concurrence of the angle bisectors of a triangle is called its incenter. Okay, incenter. The incenter of a triangle is equidistant from its side. Constructions of angle bisectors of a triangle. We follow the steps given below to construct the angle bisector of a triangle. Number 1, draw the given triangle ABC. 2, with A center and any convenient radius, draw an arc cutting AB and AC at X and Y respectively. 3, with X as center and a convenient radius, draw an arc. Similarly, with Y as center and with the same radius, draw another arc cutting the earlier arc at 0. 4, join AO and produce O to meet BC at P, then AP is a required bisector of angle A. Similarly, we can draw other angle bisectors. Encircle. A circle having center at the incenter of a triangle and radius equal to the distance of incenter from any side of the triangle is called its encircle. The distance of incenter of a triangle from any of its side is called the inradius. Okay, exercise 19.3. Number 1, in a triangle define the following. Okay, so students, you have to define median and centroid. Okay, things to remember. In an isosceles triangle, the angles opposite to equal sides are equal. 2, in a triangle, if two angles are equal, then the sides opposite to them are also equal. 3, in an isosceles triangle, median to the base is perpendicular to the base. 4, in a right triangle, if A and B are the lengths of the sides and C that of the hypotenuse, then C square is equals to A square plus B square. 5, if the sides of a triangle are of lengths A, B and C such that C square is equals to A square plus B square, then the triangle is a right angle triangle and the side of length C is the hypotenuse. 6, a median of a triangle is a line segment joining a vertex to the midpoint of the opposite side. 7, the point of concurrence of medians is called the centroid of the triangle. 8, an altitude of a triangle is a line segment drawn perpendicular from the vertex to the opposite side. 9, the point of concurrence of the altitudes of a triangle is called its orthocenter. 10, the point of concurrence of the perpendicular bisectors of the sides of a triangle is called its circumcenter. 11, the point of concurrence of angle bisectors of a triangle is called its incenter. 12, the centroid of a triangle divides each medium in the ratio 2:1. Remember that. Okay. 13, the circumcenter of a triangle is equidistant from its vertices. 14, the incenter of a triangle is equidistant from its sides. And 15, in an equilateral triangle, the centroid, the orthocenter, the circumcenter and the incenter all coincide. Students, here comes the end of this chapter. Now you will do practice of this chapter.